Okay, it's recording. I'm going to record this in case you are absent or whatever and need to, we have a couple people absent. Okay, in order for a function to be differentiable, we wrote on our notes last time. You still have your notes out last time? Who has the definition of the derivative from 3.1? There are a few things that had to happen. Your notes at 3.1, the very front, the very first paragraph we wrote. The limit has to exist, and if f prime exists, we say that f has a derivative, a function that is differentiable at every point of its domain is a differentiable function. So we have to be looking at every point of its domain, which means we need some continuous points. If we have continuous points on the domain, then it is differentiable. And I kind of mentioned this already with those jagged corners. We're looking for smoothness. What did we put on those jagged corners? Open circle, because it's not differentiable at those points. Because we're looking for the slope of the tangent line. So we have this jagged corner. Well, this slope comes up. This slope is like that, and you get two different slopes, which is why it's not differentiable. And here is our non-continuous points. Continuous points. They wouldn't be differentiable. Okay, so to determine if you can find the derivative of a point, ask these questions. Is the point in the domain? Make sure the point is in the domain. Some functions don't have a domain from negative infinity to positive infinity. Quadratics go negative infinity to positive infinity. Cubics have a domain negative infinity to positive infinity. Can someone give me an example that's not negative infinity to positive infinity? Square root. The y equals square root of x starts at x equals 0 and curves to the right. And there's nothing on the negative end unless we have a shift, right? Or some piecewise don't go from negative infinity to positive infinity. So make sure the point you're looking for is actually in the domain. Secondly, is it's continuous. Okay, we talked about this briefly already. 3 rules of continuity. Who remembers one of them? Okay, how do we say that with limits, though, and functions? The limit, the limit as we approach, x approaches c of f of x exists. Okay, that's one of them. What else do we have to have for continuity? So we're saying coming in from both sides, we get the same limit, left and right.
So limit of x approaches the negative equals limit of x approaches positive.
Well, that's the same as number 1. But f of c has to exist, or it's not continuous. You can have a limit and have a hole there, but in order for it to be continuous, there can't be the hole there. So f of c has to exist, and then those two have to be equal, meaning that hole is actually filled in, because f of c's value is the same as the limit. F of, that's a typo, f of c has to equal the limit as x approaches c of f of x. Okay. So there's actually 4 parts. Here it says 3. I'm going to add in a 4th one where the function would not be differentiable. When we have corners, so is the function differential at the point? Make sure there are no corners. Like that. The jagged edge. Because we're looking for the slope of the tangent line. Well, this tangent line is negative versus coming in from the right. We have positive, so what's the slope of the tangent line at that point? Well, it doesn't really exist, does it? Okay, also, No cusps. Cusps. That's kind of like curves come into a jagged point like that. Same issue as the corners. No vertical tangents. Can you think of a function that has vertical tangents all over the place? It does have a vertical tangent, that's true. 1 over x, the reciprocal function. Do you have a trig function? Tangent, yep. And the last one is no discontinuities, like no holes, no joint discontinuities, no infinite discontinuities. What's the other one?
Wait, so x to the power has a vertical tangent?
Of the derivative.
Of the derivative of x.
And no discontinuities. Okay, state the domain of the function. Identify where the function is continuous and differentiable. So the domain of the function on number 1. How far to the left does the graph go? How far to the right does the graph go? Does it cover all of the x values in between? Even with this hole? Yeah, because we have that redefined point up above. So the domain is negative infinity to positive infinity. The interval of continuity, though, is different. I go from negative infinity, and then I'm continuous until what x value? 2. Negative infinity to, am I continuous at 2? No, so I'm going to put parentheses, and then pick up a pencil and continue again at 2, so what do I put between my two intervals? Union. And where is it differentiable? Which means we're looking for the 4 things above not to happen. We have how many issues with this graph? 2. There's an issue with the hole. Where else is there an issue? The corner. So our interval, which we're differentiable, goes from negative infinity to 2 union. What's the next set? 2 to 4. And then we have a corner, so we're not differentiable at 4, which is why we're using parentheses, and then 4 to infinity. Does that make sense? Okay, do number 2. Okay, so for the Same answers. Is that a sketch or a question? Okay. Good. It looks like we did okay until some people left the interval where it's differentiable blank, or you're stuck a little bit. Domain-wise, this arrow tells you to go to the left forever. And then as we go to the right, we have all x values except for which values? X equals 0 and x equals 5, because there's that hole. So those are the points where we have to put parentheses for the domain. We go from smallest to largest, negative infinity to 0. We don't actually have a value at 0 because of the vertical tangent line, or the vertical asymptote. Union 0 to 5, union 5 to infinity. 7, and what comes after the 7? Bracket. Why? It doesn't have an arrow, it has an ending point that's filled in. Okay, interval of continuity is not always the same. So you can do that pencil trick, just on the AP test, don't explain saying the pencil trick. Okay, explain using limits. So I'm continuous until x equals, to get to the rest of the graph, I have to pick up my pencil at x equals 0. And then I continue on until x equals 5. So 0, 5, until 5 to... so in this case, the domain and the continuous interval are the same, versus the top one it wasn't. Why was the top one not the same? We redefined the hole. The hole is redefined up here. Cool. And then, interval for where it's differentiable is differentiable here. Are we differentiable at 0? No, where else is it not differentiable? At 4, because we have a corner, or actually more of a cusp from the left because it's curved. And then it's not differentiable at 5. So it's almost the same except for in the middle. We have 0 to 4, union 4 to 5, union 5 to 7 brackets. We just have that extra 4 to 5. Okay, flip it over. Compare the right hand and left hand derivatives to show that the function is not differentiable at the given point. Here's the absolute value. We looked at this briefly today already. So if you're going to drop the absolute value sign, there are two parts to absolute value. There's a negative part and a positive part, right? (2x minus 1). Where would this be? I'm using positive. Where would this be positive, meaning greater than 0? Where would it be positive? What? Say what? Yeah, if you solve for x, you get 1 over 2. So it's positive when x is greater than 1/2. Versus the negative version, and one of them needs the equal to. Doesn't matter which one, but one of them needs the equal to. This one is x is less than or equal to 1/2. And you can actually see where the graph would be in the function. Inside the function, there's this minus 1. Outside the function, Except for we have a multiplier. Remember our favorite guy, a times x minus h plus k? Yes or no? Remember a, h, and k's? You can graph it the way I did over there by breaking it up. You can graph it by getting a set table of values. And you can also say, okay, this is almost in the form of a, h, and k, except for there's a 2 by the x. If I get that 2 away from my x, I factor it out, I'm left with x plus what if I factor out a 2? I'm factoring out a 2 from both terms. Factoring means you're dividing it away. So 1 divided by 2 would leave you with 1/2. Would you agree that's the same? Because 2 times 1/2 is 1. So there is my shift, horizontal, there we think opposite, same. Remember that's opposite, same. So this is a horizontal shift, which direction? Did I do something wrong? Is this a minus? I can't see. Oh, yeah, you're right. I think he was in the way. Minus 1/2, because that was a minus. So opposite of minus would mean to go left or right? Right, 1/2. So we go right, 1/2. That's halfway there. If we were to draw the graph, what else would we have on it? At 0, f of 0, 2 times 0 minus 1, what do we get? -1, which is the absolute value, which is positive 1. And absolute value says symmetry, right? So if there's a height of positive 1 there, at 1, 1, we have another point. And there's our graph of f of x. So it wants you to find compare the right and left hand derivatives to show the function is not differentiable at 1/2, 0. See how that is where your vertex is? Well, from the left, f prime of x is the slope going down. From the right is the slope going up. Are those going to be the same? No.
So for f(x) equals 0, wouldn't you get 0 minus 1/2? Wouldn't it be negative 1/2 equals 0?
I just went back to this one. If I plug it in here, I get 2 times 0 minus negative 1/2, which would give me 2 times negative 1/2, which is still negative 1. Absolute value of negative 1.
Oh, okay.
I just went back to the beginning so I didn't have to use the fraction. Okay, so f prime of x from the left. Well, what's f prime of x? We've already kind of broken it up. If this is f of x from all values, oops, oh, this is the one we need. From the left, this guy's the one from the left. What's f prime of x? The limit as x approaches 1/2 from the left, what's f prime of x? Take the derivative of that guy in blue. -2. What would that equal? Oh, it's just -2. Versus the limit as x approaches 1/2 from the right. This is the function on the right side, correct? Which makes sense because it has a positive 2 and the right side is going up. So our slope should be positive. The derivative of that is positive 2 or positive 2x. It's 2 because you decrease the exponent by 1. So currently it's 1. If you subtract 1, you get x to 0, which the x disappears because timesing by 1 doesn't do anything. So this is 2. So does the limit exist? Why not? Yep, because the left and the right limits are not the same, correct? Okay, so we say it is not differentiable let's see, I should probably say f of x is not differentiable at 1/2 comma 2 because the slopes are not the same from the left and the right. You can also say, which I probably like better, the limit as x approaches 1/2 from the left of f prime of x does not equal the limit as x approaches 1/2 from the right of f prime of x. Because the f prime is talking about the slope of the tangent line, right? Derivative is the slope of the tangent line. The more you can correctly use limits in your explanations, the better. Okay, on number 2, we're going to, let's have these guys over here. Would you write the function for the left-hand side of the function? See how we have 2 different graphs? And you guys write the function for the right-hand side. You can tell the 2 different functions change there, right? Okay, so you guys give me the left-hand function. We have 2 pieces, and you guys give me the right-hand function. So what type of function do you guys have? Quadratic, right? Okay. What type of function do you guys have?
Linear. These
Linear.
don't really line up.
Okay, for the quadratic, you have it yet? It's flipped, so that tells you the x squared is negative, and it's not at the origin, it's at 4, so you got y equals, good. So that's the first part of our piecewise here. Negative x squared plus 4 for when x is less than or equal to 2. Okay, right-hand function. Were you able to find the slope? I'd say the slope was 2 over 2.
No, well, if you guys look, it looks like it goes up 2 every time. So if you go from 3 and then go
Okay.
over 4, it looks like it goes up 2.
Yeah, it's kind of poorly drawn. If you follow it down, though, would you say that the y-intercept is at negative 2?
I got it at negative 3.
Yeah. I'm going to go with negative 2. So next time I'll put distinct points. Because it's up 2 over 2. So this one should be, my alignment's off. Yep, so x minus 2. For when x is greater than, what? Greater than 2. Only one of them needs equal to. You can't put equal to on both. Okay, so take the derivative of each. Y prime equals, and what's this y prime? Take the derivative of each. Once you think you have it, check with your neighbor. That should be like 15 seconds. You should be done. Okay, Joanna, what'd you get for the derivative of the left-hand side? Oh, what did she got? Negative 2x. What do you think? Yeah? Because this currently is x to the 0 power, right? And so there's really not an x there, so when you take the derivative of a constant, it disappears. It's 0. Okay, and this one, we just get 1. Okay, is there any points of concern on this graph when we're talking about derivatives? What 2? X equals 2. Why is that a point of concern? Yeah, it's an abrupt change. It goes from kind of it's half of a cusp and half of a corner. Okay, find the limit of, yeah, I can't see that on mine, yeah, the limit as x approaches 2 from the left of f prime of x, and the limit as x approaches 2 from the right of f prime. Have that point of concern. Okay, so the limit as x approaches 2 from the left up, I would write it in. Negative 2x is negative 2 times 2, which equals what? Negative 4. Versus on the right side, what'd you get? What? 1. The limit as x approaches 2 from the right, I would write it in, of 1 equals 1. So when these are different, what is that telling you? What, Anisha? The limit of what function? The limit of f prime of x as x approaches 2 does not exist, and what does that tell you when the limit of f prime of x does not exist at a certain point? It is differentiable? It's not differentiable. Okay, so our explanation, we would say, since the limit as x approaches 2 from the left of f prime of x does not equal the limit as x approaches 2 from the right of f prime of x. What are we going to say? What's the point of doing this? Which function? F, yeah. F of x, the original function, is not differentiable at where? X equaling 2. So if we can show that the derivatives limits from the left and right are different, meaning the limit of the derivative at that point does not exist, then that means the function, the original function f of x, is not differentiable at that point. And this is one of the cusp and corners issues. Okay, I think the rest is just the review. Okay, find the derivatives. Let's practice those. Find the derivatives using that power rule of 1 and 2. Be careful when you get to those fractions. What is pi? Is pi a variable? The constant. Okay. So, number one, you bring down that 5. I'm going to show all the steps in between, but you'll eventually get to the point where you don't have to write all these steps in between. And then we do 5 minus 1, right? Bring that 3 down. Remember, it's being multiplied to the original, except for we do 3 minus 1 minus 3. This is a 1. Does bringing down a 1 really do anything? I can bring it down just for practice, but x to the 1 minus 1. And constant's derivative of the constant would be 0. So y prime becomes 15x to the 4th plus 6x squared. This becomes x to the 0, so the x's is gone. It becomes a constant. Is that what you got? Any questions on that one? Number 2. Ooh, fractions. Okay, 6 times 1/3 x to the, can I just skip and go right to the 5th? Are we okay if I just go to the 5th now? Minus 4 times, oops, not 4, 3 times 4x squared plus, what's the power on the x? 1, so I'm bringing down a 1. 1 times pi x to the 0 minus derivative of a constant is 0. So you should get y prime equals 2x to the 5th minus 12x squared plus pi, because x to the 0 is just 1, right? Any questions on those? Did you get them? Yeah? Okay, testing your knowledge here of what the graph does on the regular function compared to f prime. Here is f of x. We're going to graph f prime of x. I would always start where the tangent line is 0. So where are we going to have a tangent line of 0? Oh, A, B, and C. Does this have smoothness, or does it have like corners that we're going to have to put open circles? Smoothness, so we can connect. So at A, B, and C, you have zeros. Interesting that we call that a 0, right? The slope is 0, and we call x-intercept solutions x-intercepts, and we also call them zeros.
So,
Okay. Now, here, as we are approaching A from the left, increasing or decreasing? What? So our f prime would be negative, meaning below. And this isn't as nice as the other one we did in class where we could find the exact slope. You can do that on number 4, but not on number 3. Okay, and here we are increasing, so our graph should be positive until the next point. And then it's decreasing until the next point. And then, and actually you could even say right here, you have the minimum, because remember that change from concave down to concave up will give you a minimum. And then increasing, something like that, with smoothness.
So it's like you took the graph and just like straightened it along the x-axis.
Maybe. Okay. Why don't you guys try 4? First thing I would do is identify where the tangent line has a slope of 0. Also, I'd be careful on this one because I can see corners, abrupt changes, so those are going to be open circles. And since it's linear in each of the pieces, you can actually find the slope and plot accurately. Okay, where did you find the slope of 0? X equals 2 to 4. And I would put open circles on the ends of those. Why do I need those open circles? Because of the corners, it's not smooth. Okay. From here to here, what's the slope of that? 3. 3 over 1 is 3. It's increasing, so it would make sense that we get a positive number. So I would do, let's see, this is at negative 3. There's negative 3, 1, 2, 3. Filled in circle until, what do I need to put on the right end? Open, because I have a corner. And then this guy, decreasing, I should get a negative number. How many does it go down?
You have them write 0.
Oh. Sorry. It's shorter. Better? Alright. How many do I go down? 6. Anyone? Anyone? Negative 6, and over to the right, how many? 6 and 4, so negative 6/4 is, which is negative 1.5, until positive 2. So that one goes from negative 2 to positive 2. Negative 2 to positive 2, negative 1.5. And then finally, we go up 3 to the right 1. That last guy has a slope of 3. So for the derivative, we would show the slope again at 3, open to closed. Derivative is showing the slope of the tangent line of the function f of x. Okay, really quickly, is there a number 5 down here?
Is that now for point x equals negative 2? Is one of them supposed to be filled in?
No, because of the sharp corner. That'll be open. This will be open. This will be open. This will be open. Okay. Draw this, and what are the points of the domain? Let's see. For x less than or equal to 1, if we put in 1, we get 1 squared minus 1, which is just 0. And it's equal to, so we have a filled-in point at, we plug in 1 and we get 0. What happens when we plug in 0? Zero squared minus 0 is just, that's interesting. I'm sorry? I'm less than or equal to. Okay, and it's concave up, so my graph's going to be going like this. Because if I found 2 points of symmetry, I have a vertex in between them. Okay, x greater than 1, well at 1, 1 minus 1 is 0. So that's right here. That's nice. It's right on that, which means we're going to be continuous. And 2 minus 1 is 1. So now I have a linear function from there. What are the points in the domain of h of x? All real numbers, negative infinity to positive infinity. Is the function h of x continuous? Actually, accidentally I told you this. Is it continuous? Because the first function ends where the second function starts. So, yes. On negative infinity to positive infinity. What x coordinates is h of x possibly not differentiable? Possibly, and I like the word that says possibly, at x equals 1, how would we know if it's differentiable or not? With the limit of the derivative. So you find the limit as x approaches 1 from the left of f prime of x. See if that's equal, I'll put a question mark. The limit as x approaches 1 from the right of f prime of x. If those are equal, then it is differentiable. If they're not equal, it's not. Okay, we'll have to stop right there. So you guys have your homework sheets, right?